morning. This is Ms. Millerbeck, and today we're going to talk about the use of letters in algebra. So if we buy a pound of apples for $1.69 a pound, we pay $1.69. So $1.69, and this little bar here, which looks like a fraction, means per. So $1.69 per pound times 1 pound equals $1.69. So that's how we write what's said here. So what if we don't know how many pounds of apples that we're buying? So if we say N equals the number of pounds, then we'd write $1.69 per 1 pound times N pounds equals $1.69 times N, which would be the total dollars that you would pay to buy the apples. So that's an example of how we might use a letter to represent an equation, and that's where we get into algebra. So here's some other examples. So Mary is 9 years old. Find her age after 3 years. So she's 9 years old. So she has 9 years plus 3 years. So she's 12 years old. Okay, what about if she's 10 years old? So 9 years, 10 years later, sorry. So she's 9 years old, and this is 10 years later, and she's 19 years old. But what about t years later? Well, she's 9 years old, and we don't know how many years we're going to add, but we're going to write t. So that's going to equal 9 plus t years. All right, so that's an algebraic expression right here. All right, let's look at this one. Okay, so we have a worker's salary is $200 less than 1/3 of a manager's salary. What's the worker's salary if the manager's salary is $7,200? Okay, so let's go back and look at this, because I know when you see a lot of words, you get crazy. Like, no, what a word problem. Okay, so the first thing we need to look at is it's 200 less. So what 200 less means is minus 200. Then it's 1/3 of the manager's salary. Well, if this is the manager's salary, we're going to write 1/3 of 7,200 and then minus 200. So now we can figure out how much the worker is making, because this is the worker, his or her salary, the worker's salary, is 200 less than 1/3 of the manager's salary. So the manager's salary times 1/3 minus 200 will give us the worker's income. So 1/3 of 72. So if we divide 7 by 3, that's 2, carry a 1. And then there is 4 3s and 12. So that's 1/3 of 7,200. Then we subtract 200. So the worker's salary is 2,200. And let's try 9,000. So we have 1/3 of 9,000 minus 200, because it's 200 less than 1/3 of the manager's salary. So this is 3,000 minus 200 equals $2,800. And then if we have M for the manager's salary, that's 1/3 M minus 200. And we have an algebraic expression. Voila! So let's see what else we have. So the price of a cup is $5 and the price of a plate is $12. Find the total price of 3 cups and 3 plates. Okay, so the price of the cup is $5, so that's 3 times $5 plus, and then there's 2 plates, and the cost of the plate is $12. So we're going to write $12. So 3 times 5 is $15, plus 2 times 12 is $24. So 15 plus 24 is $39. So let's try N cups now. So we don't know how many cups we have, but we know that they're $3. And we don't know how many plates we have, but we know that, the cups are not $3. I must have been buying them at a sale. They're $5. So the cups are $5 and the plates are $12. So if we want to write this as an algebraic expression, then we'd write 5n plus 12m, because we write the coefficient before the letter. That's very important. Okay, so that's our algebraic expression, and it'll tell us the dollars. So let's talk about operations and arithmetic and algebraic. What do they mean? So when we talk about addition, add 5 to 7. That's the sum, 5 plus 7. It also means 7 plus 5. So when we talk about this algebraically, it's add is A to B, sum equals A plus B, and equals B to plus A. Then we have subtraction. So we're going to subtract 13 from 20. Well, that means we're going to have a difference, and we're taking 13 away from 20. So we start with 20, and then we subtract the 13 that we're taking away from it. So this does not equal 13 minus 20. So we can't mix them up, okay? So we have to remember, if it's from 20, we start with 20, and then we take the 13 away. Okay? With an algebraic expression, if we subtract C from D, D is what we're starting with, and then we subtract C. So this in general does not equal C minus D. If we had 0 minus 0, then this would also, C minus D, 0 minus 0, would equal the same thing. But that's a really, really rare case. Okay, so in general, we can't switch these letters around. We'll get the wrong, it'll be either negative or positive, but it'll be the wrong sign. All right, so let's look at multiplication. So if we multiply 10 times 6, that's called the product equals 10 times 6 or 6 times 10. That's the same thing. Because of the commutative property of multiplication, we can flip these around. Just like the commutative property of addition, where we can change these around. We just can't do that with subtraction. And we can't do that with division. Okay, so these two don't have commutative properties. These two have commutative properties. So commutative means you can flip them, put one in front of the other, or vice versa, and it doesn't change it. So if we multiply g by h, the product equals g times h, or g times h, or h times g. It's all the same. Now with division, we're going to divide 24 by 3. The quotient then equals 24 divided by 3. And we can write that as a fraction, 24 divided by 3. And when we use the division house, we can remember top dog in the house. So this is the top dog. So it goes here and it gets the house. And the bottom dog has to be outside. Okay? So divide x by y, where y doesn't equal 0. So the quotient equals x divided by y. So we can write this as a fraction, x divided by y. And again, top dog goes in the house. The bottom dog is outside. So let's look at exponential notation. So if I had 7 times 7 times 7 equals, I would write that equals 7 to the third. So, or 7 cubed. So that's exponential notation. So if I had 8 times 8 times 8 times 8, that's 4 8s I'm multiplying together, then I'd write 8 to the fourth, or 8 to the fourth. If I had a times a, that equals a squared. So a squared. So when we have a 2, we don't say 8 to the 2, we say a squared. When we have b times b times b equals b cubed. So b cubed. So we don't say b to the third, we say b cubed. Then if we have c times c times c times c, there's 4 c's, so we write c to the fourth. So as soon as we change to 4, then we write to the fourth. And the same if we had 5 d's multiplying here, be d to the fifth, d to the fifth. So in general, a squared does not equal 2a. So if we had a times a, that typically does not equal the same thing as a plus a. There are some rare circumstances where this would be true, but in general, this is not true. Okay, b cubed does not equal 3b. So b cubed is b times b times b, and it does not equal b plus b plus b. So let's look at this. So we have simplify. So we see we have 2 e's. So let's rearrange this. So this is going to equal d times 1 times e times e. Okay, well, d times 1 is just d, and e times e is e squared. So that's how we would simplify it. So let's write this one. So the 5 ends alone, so let's write 4m times m times m times 5n. Okay, so we have 1, 2, 3 m's, and there's a 1 in front of this, and a 1 in front of this. So 4 times 1 is 4. Then 4 times 1, so that's 4m squared times m, 1m, times 5n. So 4m squared times 1m, 4 times 1 is just 4. M squared times m is m cubed. So we have 4m cubed times 5. Okay, so 4m cubed times 5n. All right, so we also can multiply 4 times 5. So 4 times 5, m cubed n, and 4 times 5 is 20, m cubed n. And that's our final answer. All right, so let's look at this one. We have 7t, and we know when it's divided by y, the y is down here. But then we have this expression multiplied by 2. So we can put a little 1 here, and when we come across here, we have 7t times 2 is 14t over y, because y times 1 is just y. So this would be the simplified expression. Now we want to distinguish between 3z squared and 3z, the quantity, squared. So when we look at that, we have 3z squared is 3 times z times z times z. 3z, and the whole quantity is 3z times 3z. So if we rearrange this, we have 3 times 3 times z times z. So this one is 9z squared. So this one is only, oops, I did an extra z, sorry. Okay, so this one is just 3z times z. So this one is 3z squared. Okay, so the difference is this 3 did not get squared. But when we have a quantity here, this square goes to both of them. So it's the same thing as 3 squared, z squared. If you want to think about it that way. So you can think about it this way, you can think about it this way, but this 3 gets squared, this 3 does not. So what's going on down here when we get into this? So this is -1 times x times x. We'll put a little parentheses around that. This one is -1x times -1x. Okay, so let me write that one more way. So if we know that -x, so it's -1 times x, because when we have a negative there, there's really a 1. Oh, that gets too complicated for you. Let's go back. So this is -x times -x. Okay, so the negative goes with both of them. That's easier to look at, isn't it? Okay, so negative times a negative is what? That's right, it's a positive. So this becomes x squared. And this one is -1 times x squared. So this one's -x squared. That would be a big problem, don't you think, if we mix them up? So when this is not in parentheses and there's a square on the letter, that does not mean this negative is getting squared. when it is in parentheses, that negative is getting squared. So this is the same thing as negative 1 squared x squared. Okay, so that negative goes away. All right, so last example. So express the following statements algebraically. Multiply the sum of C and D by U. Okay, so we have multiply the sum of C and D. So first, the sum of C and D. So sum of C and D is C plus D. That's a sum. So then we're going to multiply the sum of C and D by U. So we can write it this way. We can also write it this way because the commutative property of multiplication. So here we have subtract the quotient of A divided by B from the cube of V squared. Okay, so we're subtracting something from the cube of V squared. So we can start with V cubed. Okay, so we have V cubed. And we're going to subtract something. So it says subtract the quotient of an A, so that's an A, divided by B. So A divided by B looks like this, A divided by B. Okay, so if we look back at how we did this, okay, so it says the quotient equals 24 divided by 3. Divide 24 by 3. So the quotient equals 24 divided by 3, or we can write it like this, 24 divided by 3. Okay, when we do the subtraction, it says subtract C from D. Well, we had subtract the quotient from V cubed. So when we subtract, this goes first. Whatever's after the from goes first. So we look here, from the cube of V. So that goes first. And then we're subtracting the quotient of A divided by B. So A divided by B. So that was a little challenging. Okay, so that's it for this section. You have a wonderful day.